Hey everyone, today we're going to dive into something that's quietly working behind the scenes to make our AI assistants way smarter. It's called the Model Context Protocol, or MCP for short. And honestly, it's the key to teaching AI how to actually talk to the world around it.
It's a funny question, right? We've got these incredible AIs that can compose beautiful poetry, they can write thousands of lines of code. But if you ask one, hey, what's the weather like right now? It hits a wall. And why is that? It's because these powerful models are, for all their smarts, totally cut off from the real live world. And this gets to the heart of what developers call the AI in a box problem. The AI is basically trapped inside its own digital world. It has no idea about live data or services or any of the tools we use every single day. And that disconnect, it's a huge hurdle to making AI a truly helpful dynamic assistant in our lives. So how do we break the AI out of that box? Well, what we need is a common language, some kind of universal standard so that everything can communicate. And that, right there, is exactly what the Model Context Protocol is all about. The easiest way to think about MCP is like a universal translator for AI. Or even better, think of it like a USB port. You remember before USB, right? Every single device had its own weird, clunky plug. MCP does for AI what USB did for all our gadgets. It creates one single standard way for any AI to plug into any tool. No more custom work, no more messy adapters, it just works. So in any MCP chat, you've really only got three main players. First, there's the MCP host. That's your main AI app, like a chatbot or your coding environment. Then for every tool that host wants to talk to, it spins up an MCP client. And on the other end of the line, you have the MCP server. And that's the actual external tool itself, like a weather service, that's ready to provide its data or abilities.
Okay, so we've met the cast of characters. But how do they actually talk to each other? Let's pop the hood and see how this whole thing actually works.
MCP is actually designed with two really simple layers. You've got the data layer, which is the what of the conversation. It defines the messages, the vocabulary, basically the rules of what can be said. And it uses a standard called JSON RPC. And then you have the transport layer, which is the how. It's the delivery service. It decides how those messages get from point A to point B, whether that's locally on your computer or all the way across the internet using HTTP. So to get things started, a server basically puts out a menu of options. These are the core building blocks, or what the protocol calls primitives. It can offer up tools, which are actions the AI can ask it to do. It can offer resources, which is data the AI can read. And it can offer prompts, which are just handy, reusable templates to make interacting a little bit easier. Okay, I know that all sounds a little abstract, so let's make it super concrete. We're going to walk through a really simple example, step by step, to see exactly how one of these MCP conversations actually happens in the real world. All right, so here's our scene. We've got our main AI application, the host, and it wants to find out the current weather. And to do that, it needs to talk to an external weather tool, which is going to act as our server. Simple enough. And pretty much every conversation follows these four basic steps. First, there's a handshake where they introduce themselves. Then the AI asks the tool what it can do. Next, it asks it to actually perform one of those actions. And finally, the tool can send updates all on its own. So let's break them down. So step one is the handshake. It's just like two people meeting for the first time. The client connects to the server and they check in. They make sure they're speaking the same version of the MCP language and they tell each other about any special features they might support. It's all about getting on the same page. And here's a little peek at what that looks like. It's not scary, right? It's just a simple, clean message. The client says, hey, my method is to initialize and it confirms the protocol version it's using. That's it. A nice, clean start. Okay, once they've shaken hands, the client basically asks, so what's on the menu? It sends a query to the server to get a full list of all the tools and actions that it's able to perform. And the way it asks is just so wonderfully simple. It's just a message with the method tools/list. In response, the server sends back this detailed catalog of everything it can do, what each tool is called, and what info it needs to run. So now the client has the menu. It sees there's a tool to get the current forecast, and it says, yes, I'll have that. It makes its order, it calls that specific tool by its name, and it provides all the necessary info, or what we call arguments. And the request itself is just crystal clear. The method is tool/call. It specifies the exact name of the tool it wants, weather_current. And it gives it the arguments it needs. In this case, the location is San Francisco. There's no guesswork here. Now this last step, this is where things get really smart. Instead of the AI client having to constantly bother the server asking, anything new, anything new, anything new, the server can just send a notification. If it adds a new feature, like a 5-day forecast tool, it can just tell the client proactively, hey, I've got something new for you to check out.
And that message is just a simple little heads up, notifications/tools/list changed. As soon as the client gets this, it knows, okay, time to ask for the tools/list again and see what's new. This makes the whole system super efficient and keeps it perfectly up to date without wasting any effort.
So, we've walked through the mechanics, the nuts and bolts, but let's zoom out for a second. Why does having a standard like MCP matter so much? Why is this such a game changer?
Well, when you have a common language, it just breaks down all the walls. It means an AI can look at a single unified list of every tool available to it. It lets that AI react and adapt to changes in real time. It gets rid of all that inefficient checking for updates. And, maybe most important of all, it creates a real plug-and-play world, where any developer can build a cool tool and it can just work with any AI. And what that means for all of us is the end of that AI in a box. Instead, we get AI applications that aren't isolated anymore. They're deeply connected to a whole world of data and services. They become more powerful, way more responsive, and just a whole lot more useful in our actual lives. And that really leaves us with a pretty exciting question to think about. Once this universal language really takes hold, what new kinds of intelligent tools are we going to be able to build? What becomes possible when any AI can safely and seamlessly talk to any tool anywhere in the world? The possibilities are honestly just incredible to imagine.